Okay, so we were talking about the relationship between YTM and the bond price, and we said that if the coupon rate is higher than the YTM, it will increase the demand for the bond, which will translate to an increased price, and once the price increases, the yield on the bond comes down to the market yield. These are the dynamics of the relationship between the bond and the YTM of a bond. Now, we come to the implied assumptions that are embedded when we calculate the YTM of a bond of an instrument. There are two fundamental assumptions. The first assumption is that you see the reinvestment rate equals the YTM. What is reinvestment rate? I will come back to it in a minute. The second is that the investor who is doing the YTM work, who is working out the YTM is working on the premise that he will hold the bond to maturity. Let us come back to the first one, reinvestment rate. The rate at which intermediate coupons, you see when you invest in a bond, particularly a coupon bond, you get cash flows from the bond in terms of interest payments at periodic intervals. It may be 6 months, may be annual, it depends on the contract of issue of the bond. So, these intermediate cash flows can be reinvested by the person holding the bond. He gets the cash, he gets money into his bank account or his and he can reinvest that particular amount, reinvest that coupon or the credit that he gets into the bank account in an appropriate, in a desired manner. That is where the issue of reinvestment comes into play, the issue of reinvestment rate comes into play. The rate at which these intermediate cash flows, whatever they may be out of, so long as they arise from holding the bond, they may be coupon payments, they may be interest payments, they may also be principal repayments if the principal repayment is staggered. So, when these cash flows are reinvested, the rate at which they are to be reinvested or the assumed reinvestment rate or the actual reinvestment rate, as the case may be, is called the reinvestment rate. Now, the issue is that when we work out the YTM, an implied assumption, you do not make that as no, I would like to make this very clear. You do not explicitly make this assumption, it follows from the formula itself, from the computation formula of YTM, that all intermediate cash flows are reinvested at the YTM itself. Whatever YTM is worked out, the formula implies that all intermediate cash flows are reinvested at the YTM itself. You can easily see that. In fact, we have the formula P 0 is equal to let us take a 2 period bond for simplicity, 1 plus y plus 1 plus y whole square, or this can be written as P 0 into 1 plus y squared is equal to C 1 into 1 plus y plus C 2. It is very clear that this intermediate payment C 1 is being reinvested at what rate? At the rate y. So, that is an implied, no, I did not make that assumption, there was nothing exogenous about it. This very computational formula implies this particular assumption that all intermediate cash flows are reinvested at the YTM rate. You can see this as an example. You have got two bonds A and B. Bond A is a 2-year 0 coupon bond, that is, it is going to give you 1150 at the end of the second year. Current price at a YTM of 12% works out to 916.8. Bond B is a similar bond, but it has a maturity of 1 year. And it has a maturity of 1 year, given that it has a YTM same as bond A, the redemption value is worked out as 1026.8. Therefore, because the YTMs and obviously the market prices being the same of the two bonds, we must have that the future value of this amount must be this amount at the reinvestment rate. In other words, if I reinvest this intermediate payment at the end of 1 year, I should get this amount at the end of the second year. And when you work that out, When you work out that rate, it turns out to be precisely 12%, which is the YTM. So, it is very clear both through conceptual analysis as well as by this abridged example, that the reinvestment rate is equal to YTM is a fundamental embedded assumption. I reiterate the word embedded. It is an embedded assumption of the YTM computation formula and hence the YTM concept itself. But why and why are we discussing all this? That is a very important question. Let us see the implications of this assumption. The implications of this assumption become very clear in the next example. We have two bonds, bond A and bond B. This is a very interesting example, we will go through it slowly. Bond A and bond B. The coupon rate of bond A is 10%, bond B is 3%, the face value is 100 of both the bonds. The current market price of bond A is 138.90, the current market price of bond B is 70.22. The maturity of the two bonds is 15 years, so that is irrelevant. Frequency of payment is also annual, and the yield, now the yield to maturity of bond A is 6%, bond B is 6.1%. The reinvestment rate given is 9%. In other words, the rate at which these intermediate coupons would be invested, would be reinvested is 9%. That is what the investor presumes would be the appropriate rate at which he wants to reinvest. Now, the question is, which bond is better? Prima facie, if you go by the YTM as a measure of betterness, as a measure of superiority of a fixed income security of a bond, then bond B happens to be superior. It promises a higher YTM of 6.1% compared to A, which has a YTM of 6%. Let us look at the actual figures. At a reinvestment rate of 6.66%, remember we are talking about a reinvestment rate of 9%. Okay, but I have worked it out at 6.66%. The reason for this will become clear shortly, but for the moment let us start with the reinvestment rate of 6.66%. The reinvested coupons of A, remember A has a coupon rate of 10%. So, at the end of every year you are getting 10 units of money as the coupon. B has a coupon rate of 3%. So, at the end of every year you are getting 3 units of money for reinvestment. Over 15 years the reinvested coupons translate to 243.68 rupees, and in this case, because the coupon rate is 3%, so every year you are getting 3 rupees, and if you reinvest this entire amount at 6.66%, you get 73.10. Redemption value, I have worked out back calculated by using the YTM figure. I am given the coupon rates, I am given the YTM. So, I could work out the redemption value. It comes out to about 100.122, 100.321. These figures are probably due to rounding off in the question. So, but as a check I worked out the redemption value, and the redemption value worked out to these figures. I could work out the redemption value because I had the YTM figures, I had the market price and I had the coupon rate. So, I could work out the redemption value, and they turned out to be around 100. So, the total of all this at a reinvestment rate works out to 343.80 and 173.42. But please note, the bond A is quoting as 138.90, bond B is quoting at 70.22. So, we need to work out the cash flows, the total cash flows per rupee of investment, per unit of money of investment. Please note, the investments are different, and because the investments are different, the total cash flows need to be normalized with respect to the investments. And after normalizing them and working out an annual equivalent investment, we find that bond A has a return of 6.2284%, bond B has a return of 6.213%. In other words, bond A is slightly marginally better than bond B if the reinvestment rate is 6.66%. As per YTM, please recall A had a YTM of 6%, B had a YTM of 6.1%, therefore, clearly bond B was superior to bond A as per YTM. But as per, and if we have a reinvestment rate of 6.66%, this situation reverses. In fact, if you look at this at 6%, 6.1%, 6.5%, bond B continues to be slightly superior than bond A, but at 6.6% and onwards, bond A becomes superior to bond B. These are the reinvestment rates. These are the reinvestment rates. So, what is the fallout? The fallout is that YTM is not unambiguous. And why? What is the cause of this? The cause of this is that bond A is giving you a 10 rupee intermediate cash flow every year, which is now being reinvested at the rate of 9%. Bond B is giving you a much smaller cash flow, which is being reinvested at the rate of 9%. However, and therefore A giving you a higher cash flow gives you a higher reinvestment income, and B gives you a lower reinvestment income. That is one thing. The second thing is, how does it compare with the YTM rate? The YTM rate is 6%. The YTM rate is 6% for A. That means, when we work out the YTM of A, we assume that this 10 rupees every year are being reinvested at 6% per annum. The actual reinvestment rate is 9% per annum. Therefore, A is, the returns from A are superior than what the YTM is projecting them to be, and they overshadow, override or supersede the returns from B, which has a YTM of 6.1%, and therefore, that 3 rupee coupon that I get every year are deemed to be, are assumed to be reinvested at 6.1%, whereas in actual fact A involves a 10 rupee reinvestment at the rate of 9%, B involves a 3 rupee reinvestment at the rate of 9%. The differential is absolutely clear. So, this difference in the reinvestment amount contributes to enhancement of the yield of A as the reinvestment rate increases. This is the working. There is another issue with the YTM. This is relating to a portfolio. You see, we have talked about it earlier. The return of a portfolio of assets is the weighted average return of its constituents. The beta of a portfolio of securities is the weighted average beta of the constituents. Unfortunately, the YTM of a portfolio of assets is not the YTM of the constituent securities. Just look at this. A portfolio is made of equal proportions of securities A and B. The current price of A is 100 and its respective cash flows over the next 3 years is 15, 15 and 115, coupon rate of 15%. The price of B is 100 and it gives 606 and 0, coupon rate is 6%, life is 2 years. Calculate the YTM of A and B and the portfolio as well. Just look at it. The YTM of A and B are quite clear. A's YTM is 15%, B's YTM is 6%, because both of them are quoting at par. Therefore, coupon rates must equal the YTM. When we work out the YTM of the portfolio, if you look at it, the cash flows are as the aggregate of the two cash flows, the aggregate of the cash flows of the two constituent securities, and we have this amount. It works out to 11.29%. 11.29% is the actual YTM of the portfolio. The average YTM of the two is about 10.5%. So, the portfolio YTM is not equal to the weighted average YTM of the constituent securities. This is another shortcoming of the YTM measure. Let us quickly recap. Bond prices and YTM are inversely related. Value of bond is equal to face value, YTM is equal to coupon. Value of bond would be higher if the coupon interest rate is higher than YTM and vice versa. Value of a bond would decrease if as it approaches maturity, if it is a premium bond. You see, it is quite simple. Let us say a bond is quoting at higher than face value. Let us say this is my face value. I take the origin as my face value. This is my face value, and my bond is quoting here. And let us say this is the maturity. This is time. This is maturity. Then, as on maturity, because on the assumption that the redemption is at face value, I must touch this point, because redemption is going to be at face value. So, no arbitrage means what? The bond's price must equal to the face value on redemption. If the redemption is to be at face value, then on the date of maturity, the market price cannot be different from the redemption value, because there would be arbitrage in that case. Therefore, as on the maturity, the price must equal the face value. Hence, in some manner this point must reach this point. So, assuming that there are no discontinuities, no jumps and no abrupt fluctuations, and even if there are marginal fluctuations, it would be something like this. And as a result of it, this premium is likely to be amortized gradually into 0. At this point, the premium is 0. So, as time passes, as the bond approaches maturity, the premium is likely to be amortized, to be eliminated, and the bond price is likely to go down. Now, these were the shortcomings of the YTM concept. So, what do? We have an alternative measure of yield, alternative measure of return, which in fact has already been demonstrated in context of a previous problem. How is it defined? Let us see how it is defined more explicitly. If P0 is my initial investment and I invested for some particular period of time, say n years, then the annual, and if RY is the annual return that I get, which is called the realized yield or the holding period yield. Now, please note this n may not necessarily coincide with the maturity of the bond. While working, see, please understand, while working out the YTM, we made the implied assumption that the bond was held to maturity. Why did we make that assumption? Because the cash flow as on maturity was known to us, it was contractual cash flow. We know the amount at which the bond is going to be redeemed, we know the period and we know the amount, and therefore, to that extent the YTM is deterministic, or the YTM is clearly defined, because as of maturity, what is the cash outflow that is going to take place on account of redemption of the bond, and the period to maturity, both are clearly known to us, explicitly known to us, and therefore, that assumption is built into the YTM. And the issue of the price at which the investment is to be liquidated is not involved in the YTM computation. Let me explain it. You see, this is 0, I make this investment, this is the maturity of the bond, let us call it capital N, and this is my holding period T. Now, if I hold the bond up to T and T does not coincide with N, that means at this period T I must sell the bond in the market, and when I sell the bond in the market, I will get the market price. Now, market price is not determined at T equal to 0, but if T coincides with N, then I know the cash flow that I am going to get on redemption. The bond is going to be redeemed, company is going to pay back. So, if the company is going to pay money, it is going to pay money as per the contract of issue, and therefore, this money amount at t equal to n at the point of redemption is known beforehand at t equal to 0. So, it facilitates a precise or a non-stochastic or a non-random computation of the YTM. Here the situation is different. Here we have a holding period which or which can be less than the maturity of the bond, that is what how long I want to be invested in the bond. This is the period for which I am invested in the bond. I want to work out the return for that period, and this must equal to what? It must equal all the cash flows that I am going to derive from the bond at this point. What are those cash flows? These cash flows will be the future value of all those coupons at this point, all the coupons at this point, future values of all the coupons at this point, plus when I sell the bond in the market, the price that I am going to get. So, the total cash flows will comprise of the future value of the reinvested coupons plus the total price, and that gives us a slightly different measure. Now, please note the price will be an estimated price. If you work out this holding period yield at t equal to 0, the price that you are going to use for selling this bond in the market, assuming that the two dates are different, assuming that these two dates are different, will obviously be an estimated price, and to that extent this will be an estimated quantity if it is forward looking. If it is backward looking, in other words, you are calculating the actual realized yield using this formula, then obviously it is a post facto computation, it is a computation after the event has happened. To that extent, it will be useful for comparing your investment with other investments that could have been made at an earlier date. Now, basic properties of realized yield. The realized yield always lies between the YTM and the reinvestment rate, that is clear from the formula itself, that the realized yield will lie in the interval YTM and reinvestment rate. If the YTM is lesser and reinvestment rate is more, it will lie in between these two, and conversely if reinvestment rate is less, YTM is more, then again it will lie in this interval. If the bond's maturity is larger, then reinvestment plays a more significant contribution to the realization of return. Therefore, it's the realized yield or the holding period yield will bend towards or will tilt towards the reinvestment rate and vice versa. Now, we come to a slightly different measure of return. See, so far we have been talking about bonds. Bonds are usually long dated securities. Bonds are securities which have a long maturity, maybe 5 years, 10 years, 15 years and so on, 7 years and so on. There is another class of securities which have a very short maturity period, 1 year or less, which are called money market instruments. Instruments which have a maturity of 1 year or less are called money market instruments. Now, examples, we have treasury bills which are very common across the world. In fact, every country literally, or most of the countries at least, have their own treasury bills. These are issued by the central bank to finance the government, they are auctioned by the central bank, the Reserve Bank, to finance the government's expenditures. Then we have certificates of deposits, we have commercial paper which are issued by corporates. They are usually privately placed, but they are issued at a discount and they are redeemed at par value. Similarly, treasury bills are also issued at a discount and redeemed at par values. So, there is no coupon payment in such instruments. The instruments are redeemed at par value and they are issued at a discount. The difference between the discount or the price at which you buy them, which is lower than the redemption value of obviously, constitutes the return. The face value at which they are redeemed, usually they are redeemed at face value. So, the face value at which they are redeemed and the price at which they are paid, they are purchased, constitutes the return. They are usually called discount instruments, because they are issued and they are sold at a discount to face value. Now, in the context of these instruments, we have a different measure of yield which is common. Now, I would like to emphasize here that unlike what we have been talking about in earlier lectures on stock index futures and other types of futures, currency futures and so on, conventions, market conventions play a rather significant role when we talk about interest rate instruments and interest rate futures. Market conventions become very important, and although the principles are quite simple, but the induction of market conventions into the analysis makes it a bit tedious at times. Anyway, so treasury bills and such money market instruments are instruments that are issued at a discount, redeemed at face value, and their yield is worked out in a slightly different way. Normally, what we work out as the yield is the increase in price, that is P 1 minus P 0 divided by the initial investment, which is P 0, and we annualize this. How do we annualize it? We annualize it with respect to a 365-day year. That is the normal practice, that is the normal return that we work out. However, in this case it is a slightly different scenario. Firstly, instead of using P 1 minus P 0, what we use is P 1 minus P 0, that is fine, the numerator is fine, the denominator becomes P 1 instead of P 0. In other words, we measure the return with respect not to the initial investment, but the redemption value of the instrument. The change in price is taken as a percentage of the redemption value of the instrument rather than the price at which the investment was made. That is one significant massive difference between the conventional yield and the discount yield or the T-bill yield. And the second thing is the normalization that I talked about here with respect to 365 days is not done with respect to 365 days, it is done with respect to 360 days. 360 days divided by the number of days n between settlement and maturity. So, these are two significant, and thirdly, if you, as you can see here, this is a simple interest expression, it does not involve any compounding. So, there are three fundamental differences in the treasury bill yield versus the conventional bond yield that we talk about. Number one, the yield is calculated with respect to the final redemption value rather than the initial investment, number one. Number two, it is normalized with respect to 360 days in a year rather than 365 days in a year, and number three, simple interest normalization is done rather than the compound interest normalization. Let us now work out the equivalence between the treasury bill yield and the discount yield and the conventional effective yield, the annual effective yield. The relationship between the treasury bill yield that we worked out just now and the effective yield. The treasury bill yield, as I mentioned just now, is given by P 1 minus P 0 divided by P 1 divided by P 1, I reiterate, into 360 divided by the number of days between settlement and maturity. Therefore, what do we have? P 1 minus P 0, P 1 upon P 0, I am sorry, P 1 upon P 0, this on inverting it becomes 1 minus d into this divided by 360. So, you take this here, you get P 1 minus P 0 upon P 1 is equal to d into NSM divided by 360. And this works out to 1 minus P 0 upon P 1. Using this expression, what we get for P 1 minus P 0 on inverting is 1 minus d NSM divided by 360, the reciprocal of this expression. This expression gives you P 0 upon P 1, and so you take the reciprocal, you get P 1 upon P 0. Now, what is the effective yield? Effective yield, if the effective yield is IE, this is the annual effective yield, then annual effective yield is given by P1 upon P0 to the power 360. Now, please note this is compounding, because we are working out the effective yield P1 upon P0 to the power 365 upon n minus 1. In other words, 1 plus IE is equal to P1 upon P0 to the power 365 upon n, or rather 1 plus IE to the power n upon 365 is equal to P1 upon P0. Substituting the values, we get this particular relation between effective yield and discount yield. This is the effective yield and this is the discount yield. So, this is a slightly complex relationship, but this gives you the relation between these two expressions. Now, let us do an example. We have a treasury bill of the value of 100 and a tenure of 60 days, presently quoted at 99. These are the basic facts. The face value is 100, the tenure is 60 days, that is, this is face value P1 is equal to 100, P0 is equal to 99 and T is equal to 60 days. This is the data that is given to us. Let us work out the various parameters. The discount yield is given by P1 minus P0 upon P1 into 360 upon n. We have all the figures there. We have P1 as 100, P0 as 99, P 100, 360 upon 60, that I think works out to 6%. Let me check. 100 minus 99 divided by 100 into 360 upon 60, that is 6%. Then effective yield is P1 upon P0 to the power 365 upon n minus 1. This will require a computation. So, it comes to be slightly different from this figure of 6%. Now, the issues of T-bill are obviously the factors or the issues that differentiate it with the from the conventional yield. Number 1, that we are using the redemption value as the benchmark for calculating the return on investment, which is not correct. We should be using the investment, but and the second is that we are using a normalization of 360 days rather than 365 days. So, these are two fundamental differences, but market is largely driven by conventions, and this is one of the examples where conventions override what is scientifically desirable. Thank you.